Let's go through the implementation of the bisection method together. So let's first revisit the data definitions with the parameters that enter this particular program. We have four main components. As in the diagram that was shown previously, the target is going to represent the number to which we want to calculate the square root. It is also going to represent the reference for the maximum value. For those cases when, for example, we want the square root of the number 1, where the square root of 1 is itself. The minimum value is going to start at 0 because we know there are no negative values. So the domain of our information is restricted to the positive real numbers. The minimum data definition corresponds to the minimum value under which the square root cannot be found. In the same way, the maximum value represents that value over which the square root cannot be found. And finally, the candidate, that is going to set the standard to determine which minimum and maximum value we pick. Let's move to the coding section. You'll see that this part is quite straightforward. We're going to start with a while loop. And this while loop is going to take the difference of our current candidate value, raised to the exponential 2, subtracted by the target. And this is going to represent how close it is the candidate to the actual value as a square root. Because when we raise it to the exponential 2, the candidate should give the value of the target. If this value is bigger than a particular threshold that preferably is going to be very, very small, then we can keep going through the while statement. However, before we can proceed, there is a small addendum that we need to make to this evaluation, to this condition. The fact is that the subtraction of the square root of the candidate minus the target may as well be negative, which is a value that is not being considered with this relational expression. To fix that, we simply need to add the absolute value of this component. The first thing we're going to do is to recalculate the value of the candidate, something that we have here. We're simply going to copy and paste it down below. If the candidate value raised to the square is bigger than the target, it means that the maximum value should become the new candidate. Because no value bigger than this candidate can possibly be the answer to the problem of finding the square root. In the same way, we have another condition where the square of the candidate is not bigger but less than the target. In this case, we set the minimum to the value of the candidate. But there is a third case, and that is when the value of the candidate is currently set to be precisely the value that we want, the value of the target. In other words, the subtraction gives 0. That's it. If we print the value of our candidate, we should have one value that approximates the square root of our target. In this case, we have a value of 5. Let's change the target, something more interesting. First, let's go through 16 just to make sure that we weren't just lucky. And it works. Let's try something like 1. The value 1 gets an approximation that is very, very close to itself, although not quite. To solve that, we just need to add more zeros. At some point, Python itself is gonna round the numbers.